Great. Okay, thank you. So yes, the topic today is we're going to talk a little bit about the integration we've made between Mestrelab's Mnova software and ZONTAL space, and how the design ideas and allotrope formats lie underneath this and help that integration to be realized. It will be myself who's doing most of the talking today. So I'm Gary Sharman from Mestrelab. Wolfgang, I think he's going to chip in on a couple of slides and also has a demo to show you. Guy may answer one or two questions if necessary. So where I would like to start today is to ask perhaps a kind of an obvious question maybe, which is, why do we collect analytical data? And I guess the conclusion to this really is it depends on who you ask. So if you ask, as we see on the left here, scientists working at the bench, well, they want that data so that they can answer questions about their experiments. Did I make the right material? Is it pure enough? And things like this. So to them, what's really important is that they can access that data quickly, and they can access in the tools they want to help them come to those decisions as quickly as possible. On the other hand, if you ask the person in the middle here, who's the one perhaps responsible for protecting intellectual property or for compliance in regulatory submissions, they want the data to be as secure as possible and retrievable and readable in the future. Maybe they're not so worried about how quickly the data can appear in the system, but it does need to be very secure for them. And then maybe finally over on the right, we've got a data scientist. They want the data in a standard format so they don't have to worry about doing conversions between it, so that they can mine it and perhaps try and learn new things from it. So the problem with this perhaps though is it's hard to meet all of these different needs at the same time. So for example, maybe we might implement a new archiving system to store our data away securely. But if that system means that it now takes longer for that scientist at the bench to access their data than it did before, or they can't access in the tool they want to access it in anymore, that's a big problem for them because it's going to make their life more difficult. And so if we're not careful, we end up kind of with potentially a conflict between these different people because they want different things. And I guess the idea here was that we were trying to come up with something that didn't lead to this kind of conflict, that satisfied everyone. So why would we collaborate on it? Well, Mestrelab, perhaps many of you don't know, but we're a company that provides tools focused on scientists to give them answers from their analytical data. We work with NMR, LC, GCMS, and other optical spectroscopy techniques. We have some experience working with Allotrope members to convert proprietary NMR data into a common format that's stored in an ADF, a kind of proposed Allotrope format for NMR, if you like. And I believe that Guy has spoken about this at past Allotrope Connect meetings, so maybe some of you have heard about that work before. On the other hand, ZONTAL supports Allotrope data formats natively, and they have a data hub that adapts FAIR principles or adopts FAIR principles. And so we saw a synergy, if you like, between these different things, that maybe we could bring them together. And I guess the idea is that then that if what we can provide from Mestrelab, what ZONTAL can provide from ZONTAL space, and the design concepts, file formats, etc. of Allotrope, maybe we can add these together to give us something that everyone is happy with in terms of data storage and performance and so on. So to say a little bit about ZONTAL space itself, Wolfgang, I think you were going to speak to this slide. I'll let you speak to this one.
Yes. So as an extension to the previous presentation for today, where we demonstrated how we can share a sequence as a request to a data system and then receive the results. We can use the same pattern to orchestrate the complete laboratory workflow. So with the goal in the end to have a digital representation of the analytical method through all stages of that workflow, which then includes integrating with various types of devices like balancers and laser devices and CDS system, but also then to data processing systems such as Mnova, which we will be presenting here in the context of this presentation.
Great, thanks, Wolfgang. So if I go on to the next slide, then this just says a little bit about how the integration that we've built works. So at the core of it, we have ZONTAL Space Analytical Data Hub, files stored within that in ADF format, which we'll say a little more about later. And I guess the idea really is that the Mnova can be used in a couple of ways within this scenario to help enable scientists to get the results that they need. So one of those is at the bottom of the slide here, and this is automated processing that occurs on ingestion. And we will see an example of that shortly in the demo. So that could be, for example, comparing data against a structure to check if it's consistent, or it could be conversion itself. So that this could be, for example, conversion of NMR data into the ADF model that we mentioned before. So that could be happening on ingestion as data arrives into the system. And the other way that's supported is that obviously it would be fabulous if automatic analysis could cure everything and could deal with every piece of data, but that's not the case in the real world. So sometimes the scientist needs to look at that data, interact with it, and come to some conclusion, and then perhaps store the results. But they don't want to have to export that data from one system into another, and then re-export it or re-import it back into the original system. They want that to be seamless. So the idea here is that they can have a view of the data from ZONTAL space directly, interact with it, do whatever annotations they need, and then send that data back into the system as well. And underlying all of this, again, is this is the sort of ADF file format. Just to mention again, just for people that don't know, so we can support NMR, LCMS, and other spectroscopies, always focused on giving scientists answers to a particular question that they might have. So that gives you an idea of the scope of what we're talking about here. And perhaps it's worth just talking a little bit more detail about how we are applying the Allotrope framework into what we're doing. So for LCMS data that's coming in, what we're doing is we're using a model that's aligned to the LCUV model with some additional elements added into it. As I mentioned before, for NMR, we're using a proposed Allotrope data model, which was developed in collaboration with Allotrope members. And then finally, for any processed Mnova data that's going back into the system, we're using an ADF container and a model that's based on Allotrope design patterns. Wolfgang, I don't know if there's anything else you want to add to this one.
No, it's fine, thanks.
Okay, so I think what we can show you is this actually kind of in action. So we've got a couple of things that we will show you. The first one is the kind of ingestion workflow that we spoke about before, and the second one will be more the scientist review of the data. So what we're going to see shortly from Wolfgang, he's going to show you, I believe it will be some mass data going in, I think, and we will verify that against a structure, and then see what additional data has been added into that as we go through. So I think probably now I will need to stop sharing, and Wolfgang, you'll need to take control. Is that correct?
Yes, So first thing in the workflow would be, and we see that Heiko is just working with the system here, awesome. The first step in the workflow will be to create a request for measurement. So we have multiple ways how we can do that. One way would be that we use a simple UI that we have here in the system, where we select the type of request that we want to do. So in this case, we want to send a request to a marsling system. Since this is a structure verification workflow, we can select the molecule that we want to have verified, and then we can provide a list of sample IDs. And this is just the most basic type of request that we could send, having just a list of sample IDs. In the context of the Pistoia method database project, we have defined an allotrope model to represent a sequence, including multiple injections and method parameters or a reference to an existing ADF method. So this would then bring additional controls here into the user interface. Using the ZONTAL UI is only one way to do this ingestion. ZONTAL comes with a full API. So if we want to have an ELN or LIMP system sending request directly into the ZONTAL system, we could just then go to the ingest API and send a request to the system. So would have the same outcome compared to using the ZONTAL user interface. This request now goes to the marsling system, and as a result, we would get back a raw data folder, which I've prepared here. So we see all the proprietary vendor files in that folder. So for the sake of demonstration, I just remove this prefix here to make the ZONTAL system recognize that the raw data file is now available. And going back to ZONTAL in a few seconds, we will see that the files will be coming in. So the files are now processed and also forwarded to the Mnova system to do the actual structure verification workflow, which will then come in a second. Oh, so that has been processed. And while we're waiting for the process to complete, maybe we can just have a brief a preview. Here the Mnova data is coming. So as the outcome of the whole process, then we will have the process data files, and we will have the original files. We will also have a vendor-neutral representation in the Allotrope data format. So this will allow us then to create some visualizations. So for example, here we have then a viewer very similar to what Heiko has just presented. We then can see the chromogram for that data set. And then for each time point in the data set, we can pull up the spectrum that's behind this time point. So looking into the data that is provided by Mnova now as a result of the conversion, we see that Mnova has provided us with some processed information that was generated based on the raw data set. And we also see a report here that we can open to see actually the verification of the structure together with the confidence, like the 78% confidence. And with that, I hand over back to Gary.
Oh, great. Thank you, Wolfgang. Could I take that? Oh, brilliant. You've done that already. So if I share my screen, hopefully everyone can see that again. So just to go back to the slides for a second, and then I'll show you the final part of the demo. Does everyone see my screen again okay?
Yes.
Yep, we see it now.
Thank you. So yeah, just to sort of reiterate there, so we had a request, it went in, it's generated here, we already had the file ready, but then we re-ingested that file back into the ZONTAL space system. That was then sent out as a request to Mnova to analyze, and then Mnova was sending back those results that you saw there. And just to skip to show that in a bit more detail, what we have, and these are all put into an ADF container, as we said. We have the Mnova file, we have a JSON representation that contains metadata from that analysis, a preview and a PDF file as well, just to reiterate that. So if we consider now the kind of second example that we had there, and this would be of a user, could be a chemist or a scientist who wants to look at this data for themselves, and hopefully what they want is a seamless way to do that. So I'm going to do that from within the Mnova interface here. I have this particular document open at the moment with an NMR and an LCMS in it, but that's not the one we're going to focus on. What I'm going to do is go to this ZONTAL browser tab, and this shows me a live view of the files that are in the ZONTAL system. We don't have to check them one for one, but it's the same ones that you see over here within the interface here. And what I'm going to do is open up one of these just by double clicking it, and an NMR in this case that's coming in from one of these NMR ADF files that we discussed. And then I could do the kind of thing that a scientist would do. So maybe I can bring in a structure to go with that. In this case, let's just do something automatic. I'm going to run a verification on this one as well. A result might come back from that. Maybe I'm not entirely happy with it, so I think, is this right? And in fact, here, just as an example, it's kind of a nice example, because in fact, if you assume that nitrogen there is charged rather than not charged, and then I rerun the analysis, you'll see that the match improves slightly. So this is the kind of thing maybe a scientist would be doing at the bench in analyzing their sample. So now I've done that, I've assigned my NMR spectrum, everything's ready. What if I need to store this again now so people can see it in the future? So that's just as simple as going to this kind of custom button and hitting to write it back into the system. Just it asks me for a name for this sample to go in there, and that will send it back into the ZONTAL space system. There we go, the upload is complete, and probably in a few seconds time we will see that package has got back into the system, and again will have been stored within the ADF file back within ZONTAL space. We can perhaps just refresh that. There we go. In fact, it's there already. You can see that it's arrived there into the system. And in fact, just to prove this is live as well, if I refresh here as well, you can see that I see it back in my view within Mnova 2. So if I just put my slide back up again here, so I think in summary then, hopefully what we've been able to do is integrated the Mestrelab's Mnova software with the ZONTAL space. Hopefully what we've done is where we started, we've perhaps benefited all users. So the scientist still has a really simple view of their data. They can get to it quickly. They can see it in a tool that's able to give them answers from that data very, very quickly as well. And it gives us access to all the data from that hub within one analytical client. The integrations has enabled a number of capabilities: automated data processing and indexing, structure verification is in there, we've got report generation and transfer of those files. And we think this gives benefits to chemists in terms of the time they would spend processing data or analyzing routine data. So that could either, as we said before, could be done on ingestion or later by them retrieving that data, whichever made most sense for that workflow. Underlying this, as we said all along, is between the the what Mestrelab's Mnova software doing and what ZONTAL Space is doing, the kind of design elements and the ADF file format is very much part of what's being done there, and that's helping us to merge these systems together and to provide an overall solution. So Wolfgang, I don't know if there are any other final comments you would like to add there in summary?
No, I think it's a summary. Thank you.
Great, thank you very much. I will stop sharing then, and I guess we're pretty much on time.
Any questions from the audience?
Thank